So in this lecture, we want to talk about the end behaviors. What is the graph doing at its ends? Let's go back to the pictures from last lesson and take a look at those polynomial graphs. So when we're talking about the end behaviors, I'm talking about what's happening here at the end and here at the end. We say that this graph rises to the left and falls to the right. Every polynomial might do something different in between those two ends, but that's one possibility, that the graph could fall on one side and rise on the other side. Another possibility is like this graph here, where both ends are falling. We say that this graph falls left and falls right. So first we want to take a look at functions of even degree. Remember I said in the last lecture that what we're interested in with the degree is whether or not it's odd or even. So you're all familiar with the graph of y equals x squared and the graph of y equals negative x squared. We know that the first one is a parabola that opens up. The second one is a parabola that opens down. So both of these have a degree of 2. The difference is that here in the first one, our leading coefficient is positive. And in the second example, my leading coefficient is negative. Both of these are functions of even degree. Take a look at what the end behaviors are. So again, the first one has a positive leading coefficient. The second one has a negative leading coefficient. Every time we have a function of even degree with a positive leading coefficient, the ends of the graph will rise on the left and rise on the right. So what will the rest of the graph be doing? That depends on the rest of the polynomial function itself. But the ends will both be rising if it has an even degree with a positive leading coefficient. So what happens if we have an even degree with a negative leading coefficient? Well, you'll notice that both ends are falling. This will always be true when you have a function of even degree with a negative leading coefficient. Both ends will be falling. In between, the graph will do whatever the equation tells it to do. But we're interested in the ends. So those are graphs with an even degree. Let's look at the polynomial functions with an odd degree. We also have an example of functions with an odd degree. You've memorized y equals x cubed. You know what that graph looks like. And you know what happens when we have a negative x cubed. Reflection across the x-axis. So both of these have an odd degree. But in the first one, we have a positive leading coefficient. And in the second, we have a negative leading coefficient. But notice, all you have to do is know what these two graphs look like, x squared and x cubed, and then their reflections. So when we have a function of odd degree with a positive leading coefficient, notice what the ends are doing, falling on the left rising on the right. So falling on the left, rising on the right, and then the graph does whatever the polynomial function is asking. But the ends will always be falling and rising. If we have a function of odd degree and the leading coefficient is negative, then it's going to rise on the left and fall on the right. Every time, odd degree, negative leading coefficient, this is what the ends are doing. The rest of the graph, whatever the required properties are from the function. Take a look at those, take some time to memorize them, put those pages together so you can see them. I would stick these up on my bathroom mirror, beside my bed, on my refrigerator, and look at them until you have this memorized. You need to know this. You need to know the difference between the graphs with even degree and the graphs with odd degree. You need to know the difference between having a positive leading coefficient and a negative leading coefficient. Make sure you memorize this. In the next lecture, we will practice finding the degrees and the leading coefficients and determining what the end behaviors of these polynomial function graphs would be.